similar to remote focusing. If you go like off the focal plane, right, there's some aberration coming up. Like, do you see any of that in your setup, or like that's not an issue?
No. So if those objectives are matched, and in our case we go from water to air, so there's a 1.33 magnification there, it's pretty much aberration free over a decent range. So we don't need to do remote focusing. There are a lot of tricks though. Of course, you can extend it in different ways and create, virtual slits and things like this and structural illumination. But in all of this, no, we were just imaging the plane.
Someone else? Just curious, in the last section of the talk, it seemed that part of the promise is that you have both the neural signal and this something that looks like the traditional resting state in the mouse. Two questions. One is has somebody done ECOG in the resting state? And the other is, what about, you mentioned sort of the mouse zoning out, but there's a fair amount of work done on sleep states and on these sort of zoning out periods in the mouse. The electrophysiology.
Right,
of
sharp
that,
wave. Yeah.
and so forth. I'm just curious if you've made contact on either of those.
Right. So I didn't mention it because I had maybe too many slides, but the grant that we have to study this is a Brain Initiative grant that includes collaboration with the epilepsy physiologists at Columbia. So I've got a student working there who's analyzing, we've got 8 days of epilepsy patients in their beds, video recordings, while they have stereo EEG electrodes penetrating throughout their brains. And so he's doing exactly the same thing. So he's looking at these correlation dynamics and he's relating them to when people walk in the room or when the patient falls asleep. It's early days, but in the grant I had a section called like, what have we been calling this all along, right? And I'm sure that it relates to what we classify as like different EEG states. I'm sure that, a lot of people have just been calling it noise and throwing it away. I would love to just get some sort of reconciled description of what it is so that we can really link those macro scale things that we sort of know about in humans to the cellular level representations that tie this back into sort of cellular level neuroscience, right? But so that's my hope, that we'll get that crossover and kind of circle back to the mouse and make some sense of it. Yeah, exactly.
One last question.
Just out of curiosity, so most of what you showed was focused on cellular resolution and lower back objectives. I was curious how to the extent the same approach to look at subcellular resolution and what are the notifications there?
Yeah, so there's a group in California, Bo Huang's lab, who is now building the subcellular resolution versions of this. And I mean, sure, everyone's like, can you image exosomes? And I'm like, what's an exosome? But so it can be taken in that direction. I mean, it's a huge space to play in, and my focus has really been on speed, because the faster you go, the more stuff's happening, and I'm just really captivated by that. So we've been thinking, actually, we're building a meso version to do 5mm field of view, so we can start to look at like intralayer dynamics and things like this over large areas. So, but yeah, you could go to smaller. I think the place we're thinking of going is just into like slices to look at synapses and things. I think that's an easier place to deliver this kind of speed to studying like that level of interactions in the nervous system. But other people who know more about exosomes and cell culture and stuff are extending it in that direction also.
All right, let's thank Elizabeth again.